Protocols define a set of methods, properties, and other requirements that fit particular task. The protocols can be adapted by classes, structures, or enumerations that provide actual implementation of those requirements. Let's consider an example when we have shapes. So we have rectangle and with properties such as width and a height. Let's create an initializer. And let's create another shape, which will be circle. It will have a radius. And let's create another shape, triangle, and with no properties right now, for now. And let's assume that we want to calculate the area for the shapes and a step triangle. So we can create a new property, area, which will be computed property. It will return the area based on the properties, stored properties of the structures. Area double turn pi multiply by radius square. So let's assume that we want to create an array of shapes, and for now
It's 21 hours.
It will be any shape, and so we can add our shapes to this array. Actually, let's create an instance of the structures, rectangle, circle, and triangle. So we can successfully add our structures to the shapes array. And this now is a new array. But what if we want to create an shapes array of shapes only if we can calculate the area of those shapes, for example, and we can calculate the area of rectangle, circle, but we cannot calculate the area of triangle. But we're not checking right now, so that's when we can instead of creating new property for the structures, we can actually create the new protocol. And so if a shape needs an calculated array, we can then conform to the protocol. And let's create a new protocol, area. So it will have area, and it will only be gettable. Protocols property can be gettable and settable. So in this case, the property is only read-only. So instead of creating property inside the structure, we can actually state that we need to conform to the area. If we want to calculate the area for the shape, we need to conform to the protocol area. And so in this case, it will say that we need to conform to the protocol area. So this means that we need to create this property inside the structure. So it will be shape and it will return width and height. So in this case we can also conform to this particle. So in this case we can say that only the shapes that conform to the particle, area must implement those requirements. In this case, it's required that the shapes that conform to the particle area require to have a property area. So we have confirmed that these two structures are conforming to this particle. And triangle is the structure that not conforming to the particle. The triangle shape will not have a property area. So when we're creating the shapes, we can actually use the fact that protocols can be used as a types. So instead of any, we can assume that only the elements that conform to the particle area can be stored in this area of shapes. So let's actually create our instance. Rectangle. And triangle. Let's append rectangle, add circle, and then add triangle, which will cause an error because triangle does not conform to the particle area. So in this case, we can eliminate all the shapes that do not conform to the particle area. So we only have an area of the shapes where we can calculate the area. So actually, let's test. Let's see if you actually can calculate an area for the shape. So this will return an area for rectangle, which will be 100. Yeah. So the protocol, and so as it says in the definition, we created the methods, which in this case we created the property, and all these structures that conform to this protocol implement the requirements for this protocol, and we can actually conform to two or more protocols. And if we want, for example, create a new protocol, let's call it draw. So it will have a method draw. So this means that this method will draw the shape. So we can conform to the protocol draw. And as it says, to conform to the protocol, we need to implement the requirements for this protocol. So let's create function draw. Drawing a rect. Drawing a circle. And we actually conform the triangle to this protocol also. And we can create this method drawing a triangle. Let's make it rectangle for consistency. So both three of the shapes conform to the draw protocol. So in this case, we can create a new array of shapes that conform to the protocol draw. So in this case, we can now append the triangle to this array. But we can also, there is a concept of protocol composition. So in this case, let's assume that we want the shapes that can calculate the area and also can draw the shape. So using the protocol composition, we can say that any element in this array must conform to the protocol of area and protocol of draw. In this case, triangle is only conform to the draw protocol and cannot conform to the protocol area, and triangle, we cannot add the triangle right now in this array. And protocols can also inherit from other protocols. So let's create a protocol paint that will inherit from protocol draw and add new additional method paint, and let's actually conform to this protocol. And now we need to implement the paint method from the paint protocol, but actually we can extend the protocol and create default implementation for this method. In this case, we are not required to provide an implementation for this protocol, but actually, let's see how it will work. Okay, let's call rect paint method and we'll paint in, and we actually provide our custom implementation for this method. Painting rectangle. Let's run, and as you can see, we have now provided the custom method for this custom implementation for this paint method, and we can also extend the types that we don't have an access to and provide our new methods. For example, let's create protocol palindrome with where variable is palindrome, which will be boolean and read only, and let's string to conform to this palindrome protocol and provide an implementation for this palindrome method. So will return true. For now, let's say it will return always true. So actually we don't have we can create and add a new property to the string, but with an extension we can add a new property using confirming that the string will saying that the string will conform to the protocol palindrome, and so we can actually extend our classes and structures and enums so to confirm some type of protocol, and protocol can only be class based, so we can restrict the protocol to be confirmed by only classes. So let's delete this one for now, and let's create a new protocol and call it border, and it will any object, so only classes can can confirm this to this protocol. So let's define border widths will be gettable and settable, and let's try our rectangle to conform to this protocol border. But it said that no class type rectangle cannot conform, non-class type rectangle cannot conform to the class protocol border. So let's create new class ellipse. Now let's conform to this protocol border and add this property. And this one, and as you can see now ellipse is a class and it can conform to the protocol border width, to the protocol border. So let's create initialize it to get rid of this error. So as you can see, rectangle is struct and it's not a class type, so it cannot conform to the protocol, which is only restricted to be conformed only class types, only classes. We can also create optional requirements for protocol. So let's consider the protocol border, and optional protocols can be only class-based protocols. So let's make this border protocol optional with optional requirements. So now border is optional, and let's import foundation, and we can now delete these lines, and we're not required to actually provide implementation for these properties, for these requirements. And also using the protocol we can modify the instance it belongs to. So let's delete these lines. So let's create new protocol shape, and it will have a method change widths that will take new widths and change the width to the new widths. And let's conform to this protocol, and we need to provide an implementation of this method and let's change the widths. And struct is immutable type, and so in order to change the widths with this function we need to make it mutating. So by making it mutating function, we can actually change the width for this rectangle. So let's print rectangle area, and then let's make it not constant, and let's change the width to 20 and print area again. So before the change it was 100 because width was equal to 10, and then it became 200. So we can also check conformance of the type to any protocol. So let's actually create an array of shapes, and it will be any, and then let's add our rectangle shape to this shapes array and check if shape in this array conforms to the protocol area. If it conforms, let's print conformed area, and let's print our actual area. Let's run. As you can see, the area rectangle conforms to this protocol, and now it prints conformed area 100. And let's say rectangle does not conform to this protocol. Run again. Nothing happens. Let's print else. Does not conform. Let's run. And as you can see, rectangle
It's 0 hours.
Does not conform to this protocol. And so we can also set in constraints for the protocol when extending some of the protocols. For example, let's have an protocol shapes, and it will have associated type. So it will be shape. Let's call it element. And so when extending the shapes, we can say that element in a shape should conform to the protocol area. So if we have, if we want to extend an element in the shapes, it needs to be conform to this array protocol. So by this one, we can actually set a constraint to extend when extending a protocol. So that's it for protocol for now. Thanks for watching. Bye.